We will be talking about the basic functioning, a very high level overview of how an MLP or multi-layer perceptron, also called a neural network, works. Okay, so typically in the neural network we have some data that we want to the algorithm to learn from. So we have some past data that we want the algorithm to learn the patterns therein, so that when we have some new data in the future, the algorithm can do a good job of making a prediction. So let's say we have some data here, x1, x2. These are also called independent variables, and x1 has some values in x2. So in other words, it might look like this, x1, x2, and then we have some y, which is the output that we want to predict. So let's say it's 1, 0, and y is 1, 1, 1, y is 0, and so on. This is the first example of data, the second example, third, so forth. And they can be, a lot of data. So let's say we have x1 and x2, and we put a neural network between them. So let's denote them by these things, 1, 2, 3. So let's say we have these 3 units of a neural network. We can also call them perceptrons or neurons. And x1 is connected to them. So it's connected to neuron 1, neuron 2. x2 is also connected to neuron 1, neuron 2. And then also there are connections between the neurons. So neuron 1 is connected to neuron 3. Neuron 2 is connected to neuron 3 as well. And then there's an output. We call it, say, y hat. It's our prediction. And let's say we are looking at the second example of data. So x1 is 1, x2 is 1, and then y is supposed to be 0. So when I say there are connections between them, these connections are actually really these things called weights. So weight 1, weight 2, 3, 4, 5, weight 6. So there are all these connections, and the signal, the input kind of propagates forward through the network to produce an output. And let's say the output produces 0.7, but we are really expecting 0, so the error is the difference, 0.7. So then the error kind of propagates backwards through the network. So this is also called a back propagation network. Okay, so the 0.7 is the error, and that kind of goes back through. And then as it's going back through the network, and you'll see in the blog post a little bit later, there's some mathematical functions, and the maths is there to, how these weights get adjusted. But basically what happens is, W5 will get adjusted by a tiny amount, call it delta, like a little amount. It'll get adjusted, and W6 will get, weight 6 will get adjusted. All these different weights get adjusted, so that hopefully the next time the signal moves forward, we produce a prediction that is closer to the actual, which we denote by y. Okay, and we do this for every example of data. So example 1, example 2, example 3, and there might be millions of rows of data. And the hope is that once we get through our data sample, that the network is doing a good job. It's been trained such that y hat, our prediction, is closer to the actual y. Now that may not be the case. We're done going through our entire data set. So let's say we have 1,000 rows in the data. So we're done going through the entire data set, but we still have significant error. Well, then we go through the data set again, and we keep going through it again and again and again. These things are called epochs. So basically, we're going through the data set again and again, so going through the 1,000 rows of data until such time that the neural network that we have is trained through this process of producing a signal and then going backwards through going forwards, producing a signal, and then going backwards through the network, adjusting the weights by tiny amounts each time, getting closer and closer to always producing a y hat that's closer to y. And hopefully after a number of epochs, and you'll see a little bit later when we go to an example of, there's an example in Excel where we try to solve a problem and it takes sometimes 300 epochs or 400. So, that it gets to a point where it's producing very little error. At that point, we call the network, the network has been trained, so that hopefully when it sees some new data that it hasn't seen before that's produced by the same process, okay, that it's producing output that's very similar, or that's very close to the actual output. And at that point, we have a trained network, and then hopefully we can deploy it and use it, and that's it. And that's our neural network.